Hello, ladies and gentlemen. Today we're going to look at triangle inequalities. And I usually start this out by asking my students, if I give you three segments, can you form a triangle with them? Any three segments? And a lot of times the students will say, yes, I can. Well, when they say that, I give them something like this and this with that. And I say, okay, form your triangle with those. And then, of course, I want you to put them together endpoint to endpoint. And if you did that like that, okay, all right, you would see that there is no way that you can make a triangle with those three side lengths, okay? And the reason being is because the sum of these two segments right here, that sum is shorter than the length of the third side there. And in order to get that triangle to form, you're going to have the sum of any two sides be greater than the third side. Okay, all right, so with that in mind, let's go through and fill out this chart here. All right, the sum of the two short sides, if we have three segments that are 2 inches by 2 inches by 2 inches long, all right, and you add these two, that'd be the sum of the two shortest sides, or, well, there is no shortest sides, so the sum of any two sides here would be 4, wouldn't it, okay? All right, and the largest possible side length would be 2. Is that sum, all right, of the two shortest sides greater than the longest possible side? And the answer is yes, it is greater. Okay, so can you form the triangle with that one? And the answer is yes, you can. All right, and now if you were to form that triangle with all three sides being 2 units long, it would look like this right here, and that's basically going to be what we call an equilateral triangle. Okay, so that one is equilateral. All right, the sum of the shortest sides. Well, the two shortest sides are 2 and 2. If I add those, I get 4. All right, and what is the longest possible side length? That would be 3. Is the sum of these two shortest sides greater than that longest side? And the answer is yes, it is greater. Okay, so could you form the triangle? Yes, you could. All right, and if you did, how many sides would be congruent? Well, you have 2 congruent, so that means it would be an isosceles triangle. Okay. All right, let's add the two shortest sides. The two shortest sides are 2 and 3. If you add those two, you get 5. And the longest side over there is 4. And when you compare the sum of those two short sides, is it greater than the third side? Yes, 5 is greater than 4. So yes, you can form that triangle. And when you do, that triangle would be a scalene triangle. All right, let's add the two smallest segments here of 2, 3, and 5. Well, the 2 and 3 are the smallest. If you add those, you get 5. The longest possible side length would be the 5. All right, is 5 greater than 5? No, 5 is equal to 5. All right, and if it's not greater, you cannot form the triangle. So the answer is no here. All right, and if you can't form the triangle, then you cannot classify it, which means we're going to put NA, or not applicable. All right, let's take the two shortest sides of the lengths 2, 3, and 6, add the two shortest sides, 2 plus 3 to get 5, and compare that with the longest possible side length, 6, okay? Is 5, that sum of those two sides, greater than this? And the answer is no, it's actually less. So can you form that triangle? And the answer is, of course, no. And if you can't form it, then you can't classify it either. Okay, let's go down to the next 3 side lengths, 3, 4, and 5. Let's add the two shortest side lengths, 3 and 4, that's 7. All right, and let's compare that with the longest possible side length, 5. All right. And 7 is greater than 5, so you can definitely form that triangle. So the answer is yes. Okay. All right. And all 3 side lengths would be different. That would be a scalene triangle. Okay, let's go to the next one. If you add the two shortest side lengths, 3 plus 3 would be 6, and you're going to compare that with the longest side length, 6. 6 is equal to 6, and it has to be greater in order to form the triangle. So the answer is no, you can't form it, and if you can't form it, you should not be classifying it. Okay, moving on. In the next one, we got 3, 3, and 3. When it says sum of the shortest side lengths, that doesn't really make sense, but if you add any two side lengths, 3 plus 3, or 3 plus 3, or 3 plus 3, you get 6. And you got to compare that with the longest possible side length, 3. And 6 is greater than 3, all right? And that means you can form that triangle. And if you notice, all three side lengths will be congruent. That means it's what we call an equilateral triangle. All right, on the next one, if you add the two shortest side lengths, 3 plus 3, you'll get 6. And you're going to compare that with 4. 6 is greater than 4, so you can form that triangle. And when you do, since you have two congruent sides, it would be an isosceles triangle. In that last one, 3 plus 5 would be 8, because those are the two shortest lengths. And then the longest length is 6, and that sum is greater than 6, so you can form that triangle. Okay, all right. And when you form that triangle, all three side lengths would be different, so that would be a scalene triangle. All right, now the triangle inequality theorem says the sum of the lengths of any two sides of a triangle must be greater than, okay, so greater than the length of the third side. All right, so let's move this down a little bit and look at the bottom part down here. Okay, determine if the following sides will form a triangle. If yes, then classify it by sides. All right, so if we take the two shortest sides, add them, 8 plus 9 is 17. Is that greater than this? 10, and the answer is yes. So you can form that triangle, and if you formed it, all three side lengths would be different measures, so it would be a scalene triangle. All right, if we take the two shortest side lengths of 1, 1, and 2, which is the two ones, and add them, that would be 2, and that's not greater than 2, so the answer is no, you cannot, and if you can't form the triangle, you shouldn't be classifying it. All right, and the next one, number 3 down here, by the way, these are numbered incorrectly. Let's fix that immediately. Okay, 6 plus 6 are that's the two shortest side lengths. If you add those two, is that sum greater than the longest side length? And the answer is yes. 12 is greater than 10, so you can form it. And if you did, then that triangle would be an isosceles triangle. All right, in the next one, it's the same as the last one. I'm not going to do that again. Okay, I don't know how that happened, but I'm not going to do it again, no need in that. Last one, if you add, there are no shortest sides, so if you add any two sides, the sum would end up being 8, and would that be greater than the other side, 4? The answer is yes, and when you do, that would be an equilateral triangle. Okay, all right, number 5 says, if two sides of a triangle, 3 inches, if two sides of a triangle, 3 inches and 10 inches, are, I should say, if two sides of a triangle are 3 inches and 10 inches, then what is the range of possibility for the third side? Well, it all depends, all right? The third side could be the shortest side, okay? Or the third side could be maybe the longest side, okay? Because that's what you want. You want a minimum value for x and a maximum value for x. So let's find the minimum first. Let's say x was the shortest side. So your side lengths would be x, 3, and 10. Well, that would mean that this sum of these two shortest sides, x plus 3, would have to be greater than 10. And if you subtract 3 from each side of that inequality, you would find that x would have to be greater than 7. Okay? All right? And what if the missing side length was the longest side? So in other words, if you had 3, 10, and something longer than 10, like x, well, the sum of the two shortest side lengths, 3 plus 10, would have to be greater than x. Well, if you add 3 and 10, that's 13. So 13 would have to be greater than x, or if you want to flip that over, x would have to be less than 13. Okay, so when you combine these two inequalities, your range would be that your side length x, whatever that length is, would have to be between the lower bound 7 and the upper bound 13. So there's your range for the possible side length of that missing triangle. Okay, let's turn the page. We have what's called the side angle inequality theorem, and it says, in a triangle, all right, the longest side length is opposite the largest angle measure, and the shortest side length is opposite the smallest angle measure, okay? All right, and by the way, that works with the other way as well. You can, the largest angle will be opposite the longest side, and the smallest angle will be opposite the shortest side. That works both ways. Please be aware of that, okay? All right, so example number 6 says, the measure of angle A, and that should say the measure of angle A equals 120 degrees, okay? And B over here is 40 degrees, and C over here is 20 degrees. Let me put those degree symbols on there. All right, and we want to know the longest side. Well, the longest side is going to be opposite the largest angle. A is the largest angle, so if you go opposite that, the longest side would be segment BC. Now, we don't know how long segment B is, but we don't care. We just want to know that it's the longest. Okay. The smallest side. Well, the smallest side will always be opposite the smallest angle. So from the other acute angles, the smallest one is the C, 20 degrees. It's smaller than 40. So opposite that will be the smallest side, which is segment AB. All right. Example number 7 says, classify the triangle by sides and then list the angles from smallest to largest measure. Okay. Well, when I look, all 3 side lengths are different lengths, so that means it's a scalene triangle. All right, and now we want the angles listed from the smallest angle measure to the greatest angle measure. Well, the smallest angle will be opposite the smallest side. The smallest side is 9, and opposite that one would be angle B. So angle B is the smallest angle. Of the 2 remaining sides, 12 is smaller than 15, so opposite the 12 would be angle C. And then, of course, the largest angle would be opposite that 15, which is angle A. Okay. All right, let's move on to example number 8. In example number 8, it says, list the sides of triangle ABC in order from longest to shortest if the angles of triangle ABC have the indicated measures. The measure of angle A is 10x degrees. The measure of angle B is 5x minus 17 degrees. The measure of angle C is equal to 7x minus 1 degrees. Well, in order for us to figure out the order of these angles, we might want to find x, okay? Well, we know that the 3 angles of any triangle add up to 180 degrees. So we could start out by saying the measure of angle A plus the measure of angle B plus the measure of angle C adds up to 180 degrees. And then we could start substitute for the measure of angle A, 10x. All right, we could replace the measure of angle B with 5x minus 17, and we could replace the measure of angle C with 7x minus 1. All right, and then if we combine these x terms, 10 and 5 is 15 plus 7 is 22, so that's 22x. And if we combine these 2 constant terms on the left, that would be minus 18. It still has to equal 180 degrees. So next we would add 18 to each side. That would give us 22x is equal to 192. So then we would divide each side by, excuse me, 22. all right? And that would give us x is equal to 9. So now that we know x, we can use it to find the measure of all three angles, all right? So let's go find the measure of angle A first. That would be 10 times 9, which is 90 degrees, all right? The measure of angle B would be equal to 5 times 9 decreased by 17. 5 times 9 is 45, and 45 minus 17, I believe that would give us 45 minus 17, 28. All right, so the measure of angle B would be equal to 28 degrees. All right, and now we'll find the measure of angle C. That would be 7 times 9 decreased by 1, which would be 63 decreased by 1. So the measure of angle C would be equal to 62 degrees. Now, the first thing I'm going to do is make sure that these add up to 180, or make sure these two acute angles add up to 90, because that's already 90, and they do, all right? So if I were to sketch it, it might help me, all right? I've got a right angle, that's angle A. I've got a small angle, that's 28 degrees over here. That's the one that's got to be B. And then over here, I'd have angle C, which is 62 degrees. And now, if it wants us to list them in what does it want? The sides. Well, the longest, which way does it want in order from longest? The longest one first, it would be opposite this 90-degree angle, which would be segment BC. So segment BC is the longest side. All right, now look at the two remaining angles. Which angle is the greatest measure? That's 62 degrees. And opposite that would be segment AB. Okay, and then the last one, the shortest side, would be opposite that smallest angle, which is segment AC. So there they are listed, the side lengths listed in order from longest to shortest. If you have any questions, please show up in a Google Meet, email me, call me, get in touch with me however you need to. Have a good day. Thank you. Bye.